negative 3 out of this will go with this, and I get M2 as 3. Don't we have the same?
Oh, thank you, teacher.
Okay, you are welcome. So you don't have to get worried. This is mathematics where we can have different ways to go, but we get to the same answer.
Mr. Matumbo, Shona's hand is up. I don't know that she has a question.
Yes, I have a question. That's
Yes.
like after finding the answer, maybe for M2 and it's an improper fraction, do we change it into a mixed fraction, or we just leave it the way it is?
You can leave it the way it is.
Okay.
You can leave it the way it is.
Thank you.
Okay. More
Then
especially
just-
when you are going to use it further, it's better you leave it the way it is, as we shall see. When we are told to get the equation of the second line. Okay, so we are done with this. That's very good.
Mr. Matumbo, John Natukunda's hand is up. Maybe we can hear what she has to say.
Okay, yes, Nakunda.
Teacher, I just wanted to do part F.
Oh, that's very fine. You're welcome. So part F here is negative 2 out of 3. That's the bracket of the first one. So is that Joan?
Yes.
Oh yes, Joan, let's move.
Teacher, wait.
Sure.
Why are you getting these questions? Like,
Where am I?
The questions, are they like in a workbook or something?
Hey,
Yes,
Mrs. Nampaj gave them to you yesterday.
Oh my goodness, me, I never saw them.
You missed them.
We have a different.
Yes.
What do you have for part F?
So for part F, we have
One whole number, 2 out of 3.
1 and 2 thirds.
One whole number?
and
2 thirds.
2 out of 3.
Okay. She told me that she picked them from here, and that's where I'm picking them from. But let me do what you have. It's very okay. Part F, what do you have?
Excuse me, teacher. Excuse me, teacher.
Yes.
So what's the name of the textbook that you're using?
Okay. Okay, it's called Discovering Secondary Mathematics Form 2.
Thank you, teacher.
Teacher, can we still use yours?
It's very fine. You know, these are numbers. You can find them here, there. This is math. We can change it to anything. So, let me do exactly what you have. So what do you have in part F, Johan?
one whole number.
1 and 2 thirds.
1 and 2 thirds, no problem.
So we first change it to an improper fraction. 1 times 3 plus 2.
1, I beg your pardon?
1 times 3 plus 2 out of 3.
So that will be 5 out of 3.
5 out of 3. Then we say M1 times M2 is equal to negative 1. Then we substitute this. M1 5 out of 3 times M2 equals negative 1. Then we multiply 3 on both sides.
Good. So 3 times 5 out of 3, M2 is equal to negative 1 times
3. Then we cross. Then we get 5M2 is equal to negative 3. Then we divide by 5 on both sides.
Okay, so 5M2 out of 5 is equal to negative 3 out of 5.
3 out of 5. Then we cross. Then M2 will be equal to negative 3 out of 5.
Yeah, that's very good, Joanne. That's very good. That's very good. So let's continue. Let me be like the president. I teach as I take my tea.
Whoever.
Wow.
Okay, so the next one. The next one.
Let's hear from the.
Is that all of people, or we have another part?
We have
Okay, which part is that one?
part G, 5 out of 2.
Okay, who is going with me, Mr. Sanjovi? Shiba? Shiba, yes, can we? Shiba. Tina Nabufu. People, let's do very fast. Let's move very fast. Who is there?
Let's hear from Denise.
Okay, Denise.
5 out of 2.
Yes, teacher. On G, we are given 5 out of 2.
5 out of 2. That's
Yes,
the
and
bracket
M1
that
is equal to 5 out of 2. Yes.
M1 is equal to
5 out of 2. So we write M1 times M2 is equal to -1.
Okay, is equal to -1. That's very good.
Mm, 5 out of 2 times M2 is equal to -1. So we multiply 2 on both sides.
Very good.
We get 5 M2 is equal to -2. We divide 5 on both sides. And our answer will be M2 is equal to -2 out of 5.
-2 out of 5. Very good. Very good. Okay. Do we still have more?
Excuse me, teacher.
Yes.
Excuse me, teacher.
0.
Yes, right. Excuse.
Teacher, what happened to the work which was on Google Classroom? Can I put it back? The notes which were there.
Can you put back the notes which were there?
Yeah.
Mr. Bato is listening. He will do the needful. He will answer that one.
Okay, thank you, teacher.
You are welcome. So do we have any other question?
Teacher, yes.
Okay, which one is that?
-0.7.
-0.7. So this is the part
H.
Part H, 0.7. Is that one
Negative.
moving? Negative.
It's negative, yes.
Is that one moving?
Teacher, me.
What's your name?
Akampulira Chonila.
Okay, Akampulira. Good.
So teacher will first turn it into a fraction. It will be -7 out of 10.
Okay, M1 is equal to -7 out of 10.
Go use those things. Teacher, I wanted to use, okay, anyway. Okay, then shall say -7 out of 10 times M2 is equal to -1.
Okay, let me first put this one, and then I do the substitution. -7 out of 10 times M2 is equal to -1.
Then we shall divide both sides by 10.
Divide or multiply?
Multiply, sorry, both sides by 10.
Okay, so it will be 10 times negative 7 out of 10 m2, which is equal to negative 1 times 10.
Then we shall negative 7 m2 divide by 7.
Okay.
Negative 7, sorry. Divide by 7. We shall divide both sides by negative 7.
Okay.
Now our answer will be 10 out of 7.
10 out of 7.
Yes.
Okay. Yeah, one can put it like that, or you can write it as a mixed fraction. And it will be there.
What about
Is that okay?
So can you write it as a decimal?
It's very fine. But in math, you know that we prefer fractions to decimals. And in a situation where we have a decimal that we are going to round off, then we encourage you to use the fractions.
Just so it doesn't matter whether the question has been given as a decimal.
Yes.
Okay.
It's not necessary. I have said that in math we prefer fraction to decimals. Okay.
Mr.
People
Matumbo,
understood?
hands up.
There is a hand up. Okay.
Tino Patricia.
I wanted to do the last number.
Yeah, okay, you are welcome. That is which part is that one?
Part L.
Part L. This one was 8. So is that part L?
Yes.
That's I.
So what is the gradient here?
0.5.
0.5. Okay. So what is M1?
M1 is 0.5. Then you change it to a fraction.
Which would be?
5 out of 10.
And we can reduce this one too.
Then M1 times M2 equals to -1.
Tino, can we first reduce this one? It's 5 out of 10, which can be reduced to
a half.
A half.
That's good. So
M1 times M2 equals to -1. Then a half times M2 equals to -1. Then you multiply both sides by 2.
okay, so this is M2 out of 2 times 4. Okay.
Then M2 equals to -2.
M2 is -2. Thank you, Tino. That's very good. I hope now everyone is comfortable with getting the second gradient given the first gradient. Teacher Martha, is there any questions?
I can see some hands up. Maybe let's hear from Tronila.
Excuse me, teacher.
Mm-hmm.
If you leave it as 5 out of 10 and you still get -2, will your method be wrong?
It will be correct, but it is easier to work with the smaller numbers if possible.
Okay.
Mr. Matumbo, there is Daniela.
Daniela, Akero.
Teacher, I don't know how to find the second gradient.
You don't know how to find the second?
No.
I beg your pardon, Daniela.
Well, okay, you talked about something about knowing how to find the first gradient of the perpendicular and then the second. So I'm not sure which one it is, but there's one I know how to do this one, but I don't know how to do the one that you talked about.
Okay, what I've said is exactly what we have been doing here. Given the gradient of the first line, how do you get the gradient of the second line that is perpendicular to this first line? And that's what we have done. M1 is the gradient of the first line, M2 is the gradient of the second line, and those two lines are perpendicular.
Okay, thank you, teacher. And then I have another question. So it's preferable to use whatever mixed fractions, or you can leave the fraction as it is.
Okay, when the gradient of the first one is a mixed fraction, you have to change it to an improper fraction before you do the substitution here.
Okay, so for the answer, so if the answer is an improper fraction, you have to change it or you can leave it as it is.
The final answer?
If it's improper fraction, you have to change it or you can leave it as it is.
In grace, you can leave it. It's very okay to leave it as an improper.
Thank you, teacher.
Okay.
Mr. Matumbo,
okay. Mwebaza, yes.
Yes, teacher, I was asking the same question. Thank you.
Okay. The final answer in this case, since we're looking at gradient, you can leave it as an improper fraction or you can change it to a fraction. Either is very fine. Okay. Is there any, I hope we have exhausted the questions.
Don't see any hand up.
Yes, that is very fine. Now, I want us to go to a situation where we are given two equations and have to tell whether those lines are perpendicular or not. Given two equations of lines, how do we tell that these lines are perpendicular? That's what we are going to. Okay? So, okay, so we are writing state whether state. Are we able to see that color of the chalk of the chalk? Okay.
Yes, teacher.
Whether state whether the following pairs of equations represent perpendicular lines. Perpendicular lines. So the first pair here is is the 2y plus 3x is equal to 2. And the second equation is 12y minus 8x is equal to 24. 12y minus 8x is equal to 24. Okay, so people, we are there. I have that first part A. State whether the following pairs, this is the first pair of equations, represent perpendicular lines. Okay, can I get someone to move with? People, I hope you prefer learning. I hope you enjoy learning math the same way I enjoy teaching it.
Yes, teacher.
Yes.
Who is there to move with me?
Yeah, Machumbe, let's have Faith Mikisa.
Okay, Faith.
We first make the coefficient of y1 using the first equation. We can say 2y.
So we say 2y
plus 3x minus 3x is equal to 2 minus 3x
is equal to 2
minus 3x
minus 3x. So you are taking 3x to the other side.
Yes, teacher. Then we shall have 2y is equal to 2 minus 3x, and we divide we divide both sides by 2.
Yes, I prefer starting with the x value here. So I want to change this from
negative 3x plus 2.
Good.
And then we shall have 2y divided by 2.
Okay.
Is equal to negative 3x divided by 2 plus 2 divided by 2.
2 divided by 2, that is dividing each term by 2. Good.
We shall remain with y is equal to negative 3 out of 2x.
Y is equal to negative 3 out of 2x.
Plus 1.
Plus 1. That's very good.
Then we shall also do that to the second equation.
Okay, let's first put the gradient here. So M1 is what?
M1 is negative 3 divided by 2.
Negative 3 out of 2. That's very good.
Yes, teacher. Then for the second equation, 12, it will be 12y. 12y minus 8x plus 8x is equal to 24 plus 8x.
Is equal to 24 plus 8x.
12y is equal to 8x plus 24.
Plus 24, very good.
We shall divide all the terms by 12.
So it will be 12y out of 12
is equal to 8x out of 12 plus 24 out of 12. Shall have y. Y is equal to, we can use 4. We can divide by 4. 2 out of 3. X plus 2
Okay.
plus 3. So
what
our
is the
gradient,
What is the gradient here?
it's 2 out of 3.
It is 2 out of 3. Is
Yes.
that okay to everyone?
Yes, teacher.
We have got the gradient of the first one, which is this, and the gradient of the second one, which is 2 out of 3. I hope that's okay. So the person I'm moving with is who?
Nikita Faith.
Okay, yeah, Faith. After getting the 2 gradients, what did you do?
We shall now use the formula M1 times M2 is equal to -1.
Before we go to that
And we
formula,
shall substitute.
Faith, can we just see what M1 times M2 is giving us?
Teacher, can I try?
Yes, I want us to see what M1 plus M2 is giving us here.
Yes, our M1 was -3 divided by 2.
-3 out of 2
times 2 out of 3. Then we shall divide, we can divide the 3 by 3 and the 2 by 2.
Here 1, here -1, here
that's
1,
-1 as
here
our
1.
answer.
So it's -1 out of 1, which is -1. Now, after getting M1 times M2 as -1, how would we conclude?
Therefore, both lines.
Yeah. Therefore, since the lines product, the product of the line gradient is -1, they are perpendicular.
Okay, that's very good. So we say that since
the product of the gradient
the product of the gradients of is -1. Yes, since the product of the gradient of the 2 lines is -1, then the 2 lines are perpendicular. The 2 lines are perpendicular. So thank you so much, Faith. Can I get questions from, if there is a question, please ask.
Yes, can I ask my question?
Mm.
You know how we said that how parallel lines have the same gradient and perpendicular ones don't. So can you just say that since the gradients aren't the same, then that means they're perpendicular, or you have to do the M1 times M2 is equal to
Oh no, it's not that lines that have different gradients must be perpendicular. They are those lines with different gradients and they are not perpendicular. The condition for perpendicular lines is that the product of their gradients must be -1. Otherwise, they are not perpendicular. Have I answered that one?
Yes, you have. Thank you.
Yes, it is only that condition M1 times M2 is equal to -1 that is confirming the perpendicular lines. There are those lines that have different gradients, but they are not perpendicular because the product of those gradients is not -1. So the steps are very clear. Get the gradient of this line by writing this in the form y is equal to mx plus c. After putting this in that form, then you can put the gradient as -3 out of 2. Go to this second line, do the same. Write it in the form y is equal to mx plus c. There you can put the m, which is the gradient, and it is 2 out of 3. After that, you multiply those two gradients. If the product of those gradients is -1, then the lines are perpendicular. If the product of those gradients is not -1, then the lines are not what? Perpendicular. Okay. If there is a question, I can handle.
Mr. Matumbo, I don't see any hand up.
Okay. Have we all understood? I want to hear some yes and then I proceed.
Yes.
Yes.
Yes, teacher.
Is there
Yes, teacher.
is there another
Okay.
method?
Is there another method?
Yes.
You suggest it to us. It's very fine, and we see.
No, I'm just asking because this one looks complicated.
And no, it's not. We said get one line, one equation, this one, write it in the form y is equal to mx plus c. Take all these other terms to the right hand side and divide it through by the coefficient of y. Is that okay? You will get it in this form. And when it is in this form, we say in parallel lines and in the gradient part that when the equation of the line is in this form, then this coefficient of x is the gradient. So we have quoted it as -3 out of 2. Do the same to this one. After getting the two gradients, multiply them. See whether the product is -1. If it is, they are perpendicular. If it's not, they are not perpendicular.
Thank you, teacher.
You are welcome. Okay. So, are you done with writing this?
Yes,
Can I
teacher.
hear one? Okay. The yes there is representing everyone. So I can clean. This was part A. I want us to look at another part. Because we said following pairs of equations. Now that was part A. We are using the same to look at part B. So part B, I can pick another pair here. I have 3y plus 5x is equal to 5y plus 3x. Okay, who can I move with? For part B, who can I move with? Teacher Martha, are you there?
Matumbo is up.
Please pick for me someone.
Teacher, we first write every equation in the y is equal to mx plus c.
Who is that one?
Teacher Angel.
Angel Ntongo.
Yes, teacher.
Oh, nice to hear from you. Can you move?
Teacher, for the first equation, 3y plus 5x is equal to 6. 3y will be equal to negative 5x plus 6.
Negative 5x plus 6. It is just taking this and the other side.
Yes.
Okay.
And then we are going to divide all those terms by 3. So 3y divided by 3 is equal to negative 5 divided by 3x plus 6 divided by 3.
Okay.
So y is equal to negative 5 divided by 3x plus 2.
Plus 2. Therefore, here m is 1. m1 is 1.
Negative 5 divided by 3.
Negative 5 out of 3. That's very good.
So for 5y plus 3x is equal to 4.
After getting the other one, then we pick another equation. 5y.
5y will be equal to negative 3x plus 4.
Negative 3x plus 4 would.
And then 5y divided by 5.
5y out of 5
is equal to negative 3x divided by 5 plus 4 divided by 5.
Plus 4 out of 5, right? Yeah, so y is equal to negative 3 out of 5 x
plus 4 out of 5.
Plus 4 out of 5. What is the gradient here? M2.
M2 is negative 3 out of 5.
Negative 3 out of 5. Are we there? Okay, so after that,
since we have both gradients now, we are going to prove whether they find out whether they're perpendicular. So M1 times M2 is equal to negative 5 divided by 3 times negative 3 divided by 5. So we divide 5 by 5, then 3 by 3. But you know a negative times a negative is a positive. So the answer is going to be
negative 1 times negative 1, which is equal to
negative.
Which is equal to 1.
1. So since the product of the gradients of the two lines is 1, and yet we know that the product of the gradients of two perpendicular lines is negative 1, the two lines are not perpendicular.
Very good, Ntongo. I like the way you have done it. I have liked the way you have done it. The product here is 1, not negative 1. There is a difference between 1 and negative 1. So the product is 1. And we say that for perpendicular lines, the product must be negative 1. So here we are saying that since the product of the gradients of the two lines is not negative 1, is not negative 1, then the two lines are not perpendicular. I hope that is very okay. The product, we are saying that since the product of the gradients of the two lines is not negative 1, then the two lines are not perpendicular. I hope that's very good. Yeah, I'm getting that. I have a feeling that everyone has understood.
Yes.
Now, I don't know whether my feeling is right or
Is right.
okay, then that's very good. Okay, that's very, very good. Now, is there any question? The next part would be given the equation of one line, and they tell you to get the equation of the second line that is passing through a given point and perpendicular to this first one. That would be that is supposed to be the next part that we are supposed to look at. But time is not on our side, and me, I prefer teaching small when we have all understood than teaching a lot when we have left some people behind. So in the remaining few minutes, 1, 2, 3, I don't want to start.
Actually, the minutes are over. So you just.
I don't want. Yes, Mr. Bato, I don't want to start on that one. So I want to give you only one. I want to give you the parts C and D of these. You try them out and see whether those pairs, whether that each pair there is of perpendicular lines. So I read it here, and then I add part C for you and part D using the same instructions here. So part C is here. Part C, I have y plus x is equal to 3, and then y is equal to x plus 4. That is part C. And then part D is y is equal to 5 minus 6x, and then a half y is equal to 1 out of 12x, then plus 1. You'll find out whether these lines are perpendicular and whether these two are also perpendicular. People, I want to end it here.
Yeah, thank you for that.
I wish you a very good day.
Thank you.